How's it going, guys? Today we're covering ground reference maneuvers. Last week we covered steep turns, and you guys seem to like it, so we're going to keep going. First, you're going to need the Airman Certification Standard. Look up ground reference maneuvers, specifically the rectangular course, and then the Airplane Flying Handbook, the rectangular course. Again, these are for free on the FAA website, and you can get a hard copy at Amazon at the links below. First thing I like to do when I'm studying these maneuvers, I like to write down the maneuver. So today we're doing the rectangular course, and I'll abbreviate today, so hopefully we can actually get some good handwriting. The principal ground reference maneuver is the rectangular course. The rectangular course is a training maneuver in which the airplane maintains an equal distance from all sides of the selected rectangular references. The maneuver is accomplished to replicate the airport traffic pattern that an airplane typically maneuvers while landing. So I would say the objective is, to replicate the traffic pattern. Replicate the traffic pattern. And we're just abbreviating. Cool. While performing the rectangular course maneuver, the pilot should maintain a constant altitude, airspeed, and distance from the ground references. The maneuver assists the pilot in practicing the following. So let's back up a second. So you are at constant altitude. In the traffic pattern, you are descending after each turn. In the rectangular course, it's all at the same altitude. So the maneuver assists the pilot in practicing the following: maintaining a specific relationship between the airplane and the ground, dividing attention between the flight path, ground-based references, manipulating the flight controls, and scanning for outside hazards and instrument indications. Adjusting the bank angle during turns to correct for ground speed changes in order to maintain constant radius turns, rolling out from a turn with the required wind correction angle to compensate for any drift caused by the wind, establishing and correcting the wind correction angle in order to maintain the track over the ground, and preparing the pilot for the airport traffic pattern at subsequent landing pattern practice. To fly the rectangular course, the pilot should first locate a square field, a rectangular field, or an area with suitable ground references on all four sides. Note that a square meets the definition of a rectangle. As previously mentioned, this area should be selected consistent with safe practices. So, refer to the risk management handbook, refer to the FAR aim for your altitudes and whatnot. The airplane should be flown parallel to and at an equal distance between 1/2 to 3/4 of a mile away from the field boundaries or selected ground references. The flight path should be positioned outside the field boundaries or selected ground references so that the references may be easily observed from either pilot's seat, because you want your DPE to be able to see it too. It is not practical to fly directly above the field boundaries or selected ground references. The pilot should avoid flying close to the references, as this will require the pilot to turn using very steep bank angles, thereby increasing aerodynamic load factor and the airplane's stall speed, especially in the downwind to crosswind turn. Okay, here is the sketch. This is what I would copy down, right? So first, select a field, a rectangle. I could probably make shapes. I could do a shape. Can I do that? Whatever. Shape, rectangle. Look at that. Ooh, man, beautiful. All right, so you're going to be selecting your field. The wind is coming from what direction here? The wind is here in the center, so I'm going to draw a little wind vector, and you're going to enter on the downwind 45 degrees. I'm just going to do regular. On the 45 degree, here's your aircraft coming in. Bam. There's the downwind leg. Face, upwind, crosswind, right? And then you can draw your little airplane. When you're downwind, by the way, this is the wind. When you're downwind, you shouldn't really need too much of a bank or a wind correction. You'll start your turn at the boundary, complete the turn at the boundary, and here you should be kind of crabbed into the wind because that wind is pushing you away from the from your reference point. You're going to start your turn here, turn less than 90 degrees. Start your turn at your boundary here. And complete your turn at the boundary. You should be upwind, not too much wind correction. Continue out, start your turn, and then correct into the wind again because it's going to push you toward it. So you're going to be crabbing, like a little crab. Neat. And then complete your turn, and then you can exit again out on the downwind like that. That's the idea. You can draw this, and you could probably do a better job than I do. I'm not an artist. The entry into the maneuver should be accomplished downwind. This places the wind on the tail of the airplane and results in an increased ground speed. There should be no wind correction angle if the wind is directly on the tail of the airplane. However, a real-world situation often results in some drift correction. The turn from the downwind leg onto the base leg is entered with a relatively steep bank angle. The pilot should roll the airplane into a steep bank with rapid, but not excessive, coordinated aileron and rudder pressures. As the airplane turns onto the following base leg, The tailwind lessens and becomes a crosswind. The bank angle is reduced gradually with coordinated aileron and rudder pressures. The pilot should be prepared for the lateral drift and compensate by turning more than 90 degrees, angling toward the inside of the rectangular course. The next leg is where the airplane turns from a base-leg position to the upwind leg. Ideally, on the upwind, the wind is directly on the nose of the airplane, resulting in a direct headwind and decreased ground speed. However, some drift correction may be necessary. The pilot should roll the airplane into a medium bank turn with coordinated aileron and rudder pressures. As the airplane turns onto the upwind leg, the crosswind lessens and becomes a headwind, and the bank angle is gradually reduced with coordinated aileron and rudder pressures. Because the pilot was angled into the wind on the base leg, the turn to the upwind leg is less than 90 degrees. Right. The next leg is where the airplane turns from an upwind leg position to the crosswind leg. The pilot should slowly roll the airplane into a shallow bank turn as the developing crosswind drifts the airplane into the inside of the rectangular course with coordinated aileron and rudder pressure. See that word coordinated? They're constantly saying coordinated. Use your rudder. As the airplane turns onto the crosswind leg, the headwind lessens and becomes a crosswind. As the turn nears completion, the bank angle is reduced with coordinated aileron and rudder pressures. To compensate for the crosswind, the pilot maintains an angle into the wind toward the outside of the rectangular course, which requires the turn to be less than 90 degrees. Right. The next leg is where the airplane turns, I already said that. The final turn is back to the downwind leg, which requires a medium banked angle and turn greater than 90 degrees, excuse me. The ground speed will be increasing as the turn progresses, and the bank should be held and then rolled out in a rapid but not excessive manner using coordinated aileron and rudder pressures. For the maneuver to be executed properly, the pilot should visually utilize the ground-based nose and wingtip references to properly position the airplane in an attitude and orientation to the rectangular course. In order to maintain a constant ground-based radius during the turns, each turn requires the bank angle to be adjusted to compensate for the changing ground speed. The higher the ground speed, the steeper the bank. If the ground speed is initially higher and then decreases throughout the turn, the bank angle should be progressively decreased. Progressively decreased throughout the turn. The converse is also true. If the ground speed is initially slower and then increases throughout the turn, the bank angle should be progressively increased throughout the turn until rollout is started. Also, the rate for rolling in and out of the turn should be adjusted to prevent drifting in or out of the course. When the wind is from a direction that could drift the airplane into the course, the banking roll rate should be slow. When the wind is from a direction that could drift the airplane to the outside of the course, the banking roll rate should be quick. Okay, the following are the most common errors made while performing rectangular courses. This is where you're going to put that. Common errors here. Failure to adequately clear the surrounding area for safety hazards initially and throughout the maneuver. So clear the airspace, my dude. Failure to establish a constant level altitude prior to entering the maneuver. So constant altitude. Failure to maintain altitude. Failure to maintain altitude during the maneuver. We'll just keep that there. Failure to properly assess wind direction. You can do that during the clearing turn. While you're looking for traffic, you can look out for ground references or like smokestacks or car dealerships. They're going to have flags over the place. Wind direction. Failure to wind direction. Close enough. Failure to establish the appropriate wind correction angle. So crab. You can actually write all these out, by the way. I'm just abbreviating. Failure to apply coordinated aileron and rudder pressure, resulting in slips and skids. Coordinate. Rudder. Failure to manipulate the flag controls in a smooth and continuous manner. Don't be jerky. Don't be like yanking the controls all over the place. So smooth. Smooth operator. Failure to properly divide attention between the airplane control and orientation with ground references. Divide attention. And failure to execute turns with accurate timing. So yeah, those are all your common errors. Now let's take a look at the ACS parameters. Going back to the Airman Certification Standard, free on the FAA website. Here are your ground reference maneuvers. This is for all of them. So S turns across the road, turns around a point, and the rectangular course. Here it says you must perform at 600 to 1,000 feet above ground. 600 to 1,000 feet above ground. 45 here. Maintain 100 plus or minus 100 feet. Plus or minus 100 feet. And plus or minus 10 knots. Not 70, that's 10. All right, and of course, read all this. Here are your references, the objective, Here's all your knowledge, the risk management, and here are the parameters that I want you to note. And of course, any notes you want to add, like, I don't know, trim is your friend, or something like maybe when you go practice it, you notice that I tend to hyperfixate on my altimeter while I'm performing these maneuvers. So keep your head out of the cockpit, look around, or something like that, right? This is really open-ended, whatever you want to add for your notes here. Okay, so that was ground reference maneuvers. If you haven't seen the steep turns one, watch this video here, and then should be good to go. Thanks for watching.